So we get the relationship as wj equals to e into s. So next relationship is n equals to, we'll move to the next relationship, n equals to vv upon v, that is porosity. So total v can be written as vv plus vs. By dividing numerator and denominator by vs, we get n equals to e upon 1 plus e, or e equals to n upon 1 minus n. The next relationship is we'll see gamma equals to w plus w upon v. W can be written as ww, weight of water plus weight of solids, to volume. Then weight of solids plus weight of water is can be written as w, water content, into ws. We have water content as weight of water to weight of soil solids, so we have written it like this. So we have the common factor, that is ws, and in the bracket we are left with 1 plus w. So gamma equals to gamma d, ws upon v, we will write it as gamma d. So gamma d equals to gamma upon 1 plus w. These are last relationship we have in this index properties. Then we'll see some more numericals. In compaction test, 0.62 kg of soil has a volume 3 into 10 to the power minus 4 cubic meter. Moisture content is 12.5%. G equals to 0.6. Determine bulk density, dry density, and void ratio. Okay. So we have been given with mass and volume. So mass is 0.62 and volume is 3 into 10 to the power minus 4. So we can get gamma, that is 2066.67 kg per meter cube. Then gamma d equals to gamma upon 1 plus w. We have seen this is the relationship. So gamma equating gamma as 2066.67 and water content as 0.125, because our water content is given as 12.5%. Then by knowing gamma d, we can find out e value, that is the void ratio, from this equation, that is gamma d equals to g gamma w upon 1 plus e. So we have found out e as 0.415. Here gamma w we have taken as 1000, because we have the unit weights in or densities in kg per cubic meter. The next numerical, we have been given with the unit weight of sand 1746 kg per meter cube. Water content is 8.6%. Unit weight of solid constituents is given as 2.6 gram per centimeter cube. Indirectly, it is given as specific gravity. So specific gravity value is 2.6. In lab, void ratio was 0.742 in loosest and 0.462 in densest state. What is relative density? So we need to find out id, that is E max minus E upon E max minus E minimum. So before that, we'll find out E value, that is the void ratio in the natural state. So for that, we'll need a gamma D value to be found out. So gamma D equals to gamma upon 1 plus W. Here we are taking 1746 as gamma, and water content is 8.6%. So we have 1 plus 0.086 as W. We can get gamma d value as 1607.7. From that, we can use this equation gamma d equals to g gamma w upon 1 plus c, and we can find out small e, that is the void ratio in the natural state. And we, with the formula for id, that is relative density, we can find out the relative density value by equating e max, e minimum, and e value, which we have just found out. So it comes out to 25.71%. So what is the interpretation of this 25.71%? So relative density less than 30% will have soil is in loose state. Okay, that is the interpretation. Then next numerical sample of sand above water table was found to have natural moisture content of 15% and a unit weight of 18.84 kilonewton per meter cube. Laboratory tests on a dried soil sample indicate a value of zero point 0.5 and 0.85 for minimum and maximum void ratios, respectively, for densest and loosest state. Calculate the degree of saturation and the relative density. Assume g equals to 2.65. So it's this numerical is identical to the previous numerical, so we need to go on the same lines. We have to first find out gamma d. Gamma value is given, w is given, so we have found out gamma d. Then gamma d equals to g gamma w on 1 plus e. We have found out e. Okay, we have used e value in this equation for relative density and found out the relative density value 66.51. So what is the interpretation of that? So id when more than 65% soil is in dense state. Okay. Then we need to also find out degree of saturation in this. That is the additional one. So we can find out degree of saturation as gamma equals to g plus e into s, gamma w upon 1 plus e. G value is given to 0.65, e value we have found out 0.617, s we need to find out, gamma w is 10, and e again 0.617. From this equation we have got and gamma value we have been given with. Okay, so degree of saturation comes out to be 64.25%. Then moving on to next numerical, mass specific gravity of fully saturated soil having water content 30% is 1.83. On drying, mass specific gravity drops to 1.6. Calculate specific gravity and shrinkage limit. So what things are given to things are gm, that is mass specific gravity, is given as 1.83. Okay, and mass specific gravity is equal to gamma upon gamma w. Okay, that is 1.83, it is given, water content is zero point 0.3, and it is given fully saturated soil, so sr equals to 1. So we have this formula, gamma sat equals to g plus e upon 1 plus e into uh, multiplied by gamma w. Okay, so gamma upon gamma w equals to g plus e upon 1 plus e. So this value is given, that is 1.83. In the numerical only it is given, that is in the form of mass specific gravity. E we have equated as Wg, because S is 1 here. Wg equals to E into Sr. In that equation we have kept S equals to 1. So E comes out to be Wg. Again here also we have substituted the same thing, and we have found out G value. And in next in the numerical it said कि mass specific gravity drops to 1.6. So that means specific gravity of solids is given as 1.6. So it is given as gamma s upon gamma w. Okay, so gamma d equals to g gamma w upon 1 plus e. As I have said, we take specific gravity of solids and uh, or unit weight of solids, and unit weight of dry unit weight of soil as synonymous, we take for this scope of geotechnical engineering. Okay. So here gamma d equals to g upon gamma w, g gamma w upon 1 plus e. So gamma d upon gamma w equals to 1 plus 6, and remaining is g upon 1 plus e. So e we have equated as wg. Okay, so this water content we have taken equal to shrinkage limit. Okay, and from this formula then we have calculated the shrinkage limit, which comes out to be 21.34%.